Okay, so here we go, moving on to some trig derivatives that are a little bit more challenging, where you'll have to use the product rule, the quotient rule, the power rule, some u substitution, or even maybe the chain rule. So here's our first example where we're going to have to use the product rule. So we're going to start with our function y equals cos of x times sine of x. And if you don't remember the product rule, it's just written out above. So if I want to find the derivative of this function, I take the first part, cos of x, and multiply it by the derivative of the second part. So you'd have to remember that the derivative of sine of x is cos of x, so that's what we're going to plug in. Then I'm going to add in the second function, so just sine of x, and multiply it by the derivative of the first function. And so here you'll have to remember that the derivative of cos of x is negative sine of x. Once I have that, then I can simplify. If I multiply these two together, I get cos squared x. And then if I multiply these two together, I get negative sine squared x. And if I recognize that this is a trig identity, I can replace it with cos of 2x. And then this one is done. So that is our first one. And then as we move on, if you are finding this helpful, please subscribe. And I would love that if you check out my website. This section here is just one of the sections on it for calculus, and it's just in specific calculus with trig. So moving on, our second one, we have the quotient rule. So we have the derivative, and same thing. If you need a reminder of the quotient rule, it's written out here. So let's just get started. So y prime is going to equal the denominator, so 2 times sine of x, times the derivative of the numerator. So the derivative of 1 is just 0, so we don't have to include it. And the derivative of cos of x is negative sine of x. And then we subtract the numerator, so 1 plus cos of x, times the derivative of the denominator, which will end up being 2 cos of x. And then this is all over the derivative, the denominator, but the denominator is squared. So we're going to simplify what we can. So we're going to multiply the 2 sine x by negative sine x, and that will give you negative 2 sine squared x. And then we will multiply the binomial with the monomial, and we'll end up with 2 cos of x plus 2 cos of x squared. Sorry, I wrote that weird. Let's put the squared over here. And then in the denominator, if we simplify, we would end up with 4 sine squared x. Now, I'm just going to draw my bracket here and distribute that negative through, and I'd end up with a negative cos squared x. So moving on from here, I can notice that I can factor out a negative 2 from the numerator. And when I do that, I'm left with positive sine squared x plus cos of x plus cos squared x. In the denominator, I still have 4 sine squared x. Now I can also recognize that when you add sine squared x and cos squared x, it equals 1. So I'll have negative 2 over times 1 plus cos of x, because I replaced that with our identity, divided by 4 sine squared x. I can also recognize that my fraction in front would reduce. So what I'm going to do as well is notice that 2 sine squared x is an identity. So I'll have that negative still out front of 1 plus cos of x, but the identity I'm going to replace with, so that 2 is still there, but sine squared x ends up being 1 minus cos squared x. Now, with that information, I can bring this further because this is a difference of squares. So if I come up here, I end up with that negative is still there, 1 plus cos of x, all over 2 times 1 minus cos of x times 1 plus cos of x. So I know this is getting messy, but we can see that this part will cancel and everything else will simplify to negative 1 over 2 times 1 minus cos of x. So a little bit long, and that's okay, we still get there. Now the next part I want to do, even though we can use the chain rule, I'm going to show some u substitution here when it's a little bit easier, and then hopefully you can carry this on when it gets a little bit harder. So when we are using u substitution, you want to differentiate in terms of x. So when I'm starting here, I'm going to say let u equal that 3x plus 4. Then I'm also going to say I'm going to take that derivative. So the derivative of du over dx would equal just 3. And then once you take the derivative, we're going to say dx over dx. And we know that this part cancels, it just equals 1. So this is how we differentiate, and it's implicit differentiation in terms of x. Now I can rewrite my function, which will be y equals sine of u, and I can take my first derivative. So if I take the derivative of u, it would be du over dx, and that will equal the derivative of sine, which is cos, so cos u, and then because it's in terms of x, it's going to be du over dx. But notice we have now du over dx, and we know what that equals. That equals 3. So we can replace that with 3. So cos of u times 3. And you can also now replace u. So I'm just going to put this 3 in the front. So you get 3 times cos of, and let's replace u back in, 3x plus 4. So that's using u substitution. You also can use the chain rule, and the chain rule would just show that if you take the derivative of sine, it's going to equal cos of what's in there, 3x minus 4. But then you have to take the derivative of the inside, which would just be 3. So we get to the same place, again, bringing that 3 out front, 3 times cos of 3x minus 4. But at least we have that practice because, again, if it gets more complicated, we still can do u substitution and differentiate in terms of x to make it a bit easier. Let's try one more, differentiating, sorry, that doesn't really make sense, in terms of x with something a little bit more complicated. So in this one, we have y equals cos 5 of x. So you may want to rewrite this first as y equals cos of x all to the power of 5. Then we can say let u equal cos of x, and then you can take the first derivative. So du over dx would equal it would equal negative sine of x, and then we can write dx over dx because it's all in terms of x. So that equals 1, so that goes away, and then we can keep going, rewriting y equals u to the power 5. Take the first derivative, so dy over dx equals 5u to the power of 4, and then once we have that, that's du over dx. Now again, we know what du over dx equals, so we can replace that in, and we can also expand this out. So we would have, going back to what we know u equals, we'd have 5 times the, what did I do? Oh, sorry, I'm looking at somewhere else. I was like, something went wrong. 5 times cos of x to the power of 4 times negative sine of x. And we can just bring that negative out front. So negative 5 cos, oh, I wrote x, but I need to replace it back in. So this was the u term of, what am I doing? No, I did that right. I did that right. I'm just confusing myself. Sorry. Cos of x to the power of 4. And then we're going to still multiply by sine of x. Okay. So I do have one more. And the same idea. You can do u substitution, or you can still do the chain rule. So in this one, if I did the chain rule just to save time, again, it's up to you, I could rewrite this as sine of 3x, and then, oh wait, no, I can't, because the squared is on x, not on the whole thing. So in this one, if I wanted to just do u substitution, which I think this one might be better, I would have u equals just 3x squared, so everything that's here. Then I can differentiate du over dx, and that would equal, to bring down, is 6x to the power of 1. And then once you took the derivative, dx over dx, and then that goes away. And then in terms of this part, you have let's just do it in steps. Y equals sine of u, and then we can take that first derivative, dy over dx equals cos of u du over dx. Now again, we know what du over dx equals, so we can do some replacing. And then we can also substitute u back in. So I'm going to write that 6x first, because usually that's what you would see first. And then it would be times cos of 3x squared. And that is what our first derivative is, so dy over dx. Okay. So as always, I hope you found this helpful. If you did, please subscribe. And again, please check out the website, all calculus. It has this whole section on trig. And if you are in Chem 30, check out my channel because there is a website for chemistry as well. Thank you for watching.